Welcome back to the Staiblocks channel. Let's jump right into today's explainer on the architect of modern reality, Emmy Noether. Look, when you think of the greatest minds in history, Albert Einstein is instantly a household name, right? But Emmy Noether? Yeah, not so much. Yet her impact on our understanding of the universe is literally monumental. So it kind of makes you ask, why isn't her name taught in every single high school science class?
Just to give you an idea of her status, when she passed away in 1935, Albert Einstein himself wrote this incredible obituary in the New York Times. He actually called her the most significant creative mathematical genius thus far produced since the higher education of women began. And it wasn't just him. Pavel Alexandrov, Norbert Wiener, absolute titans of math and physics entirely agreed. She was, without a doubt, an unquestionable titan in the scientific community herself.
Okay, let's dive into this. What exactly did she discover that was so fundamental to the very fabric of the universe? I mean, why is her work considered by many modern physicists to be on par with the Pythagorean theorem? Well, to really grasp the sheer magnitude of her genius, we actually have to first understand the immense, almost unbelievable barriers she had to break through just to do her work in the first place.
Section 1, World 1, Battling the Academic System.
So we can kind of look at her life as a tale of two worlds. The first world was her earthly struggle against the systemic prejudices of early 1900s Germany. And honestly, her perseverance was astounding. In 1907, she earns her doctorate summa cum laude. But because women were essentially excluded from academia at the time, she had to get special permission just to audit classes, and then she worked at the university for over 7 years without a single paycheck. Zero pay. By 1915, she gets invited to the prestigious University of Göttingen. But, you guessed it, still no salary. It isn't until 1919 that she's finally granted her official habilitation. But the tragedy hits in 1933. As a brilliant Jewish mathematician, she's abruptly expelled by the Nazi government. She eventually had to flee to the U.S., finding refuge at Bryn Mawr College and lecturing at Princeton until her untimely death in 1935. But here is the craziest part. Through all of that chaos, her mathematical output absolutely never slowed down. Going back to her early career for a second, the explicit sexism she faced was just staggering. When legendary mathematician David Hilbert invited her to Göttingen in 1915, the faculty literally revolted. One member explicitly protested, saying, "What will our soldiers think when they return to the university and find that they are required to learn at the feet of a woman?" Just wild. Hilbert was, thankfully, deeply indignant at this. He famously defended her by snapping back that the university was, quote, not a bathhouse. But despite all that incredible hostility, her defining trait was for sure her unbothered brilliance. She just maintained this unwavering focus on the math. There's actually this incredible historical anecdote from 1933, right after her expulsion. She just calmly continued gathering students in her apartment to discuss complex class field theory, like nothing had happened. At one point, a student even showed up to her apartment wearing the uniform of the Nazi paramilitary SA. In Noether, she showed zero agitation. She reportedly just laughed it off later and kept right on teaching. Her mind was entirely focused on the math, operating on a level way above the political darkness of the time. Section 2, World 2, Decoding the Universe's Symmetries. Now, what's really interesting about this slide is this is where we pivot from those earthly struggles to her cosmic, universe-altering mathematical discoveries. Because while she was at Göttingen, she solved a problem regarding general relativity that had completely stumped Einstein himself. Let that sink in. The result is what we now call Noether's theorem. Simply put, it's a mathematical proof stating that every continuous symmetry in nature is directly linked to a conservation law. She basically built the invisible bridge, the crucial tool that links the pure geometry of the universe with the actual physical laws that govern it. Okay, let's break that down without the dense mathematical jargon. Think of a simple visual metaphor, a rotating meter stick. This beautifully illustrates what we called invariant theory. If you take a rigid meter stick and you rotate it around, its endpoint coordinates in space are obviously changing, right? But its actual physical length, that remains perfectly constant. It's invariant. Noether was absolutely obsessed with finding these deeply hidden constants buried within the math that describes transformations. So how does this abstract idea link directly to our reality? Well, take time symmetry. If you run a physical experiment today and then run the exact same experiment tomorrow, the laws of physics are going to behave identically, right? Noether mathematically proved that because of this time symmetry, energy absolutely must be conserved. It can't be created or destroyed.
Similarly, if you rotate a physical system in space and the physical laws don't change, that rotational symmetry proves that angular momentum is conserved. I mean, it's just a breathtakingly elegant connection. Section 3. The language of abstract algebra. Her genius didn't even stop at physics. She completely revolutionized mathematics itself. Before her, mathematicians largely worked by calculating specific numbers, grinding through massive polynomials and doing really tedious computational equations. And this brilliantly illustrates her true mathematical revolution. She shifted the entire field away from specific computations and moved it toward universally valid, purely abstract concepts. She developed these groundbreaking theories on mathematical structures known as rings, fields, and ideals. She introduced this thing called the ascending chain condition, and she brilliantly united representation theory with the theory of modules. Basically, she took math and elevated it into pure conceptual thinking. To put that into perspective, her finiteness concept, that ascending chain condition I just mentioned, was so incredibly powerful and universally useful that mathematicians permanently named these structures after her. A mathematical object, like a ring or a space, that satisfies this condition is simply called Noetherian. That's the ultimate flex in math. She didn't just solve math problems, she essentially built the modern language of mathematics itself from the ground up. Section 4. Noether's enduring robustness. When we merge her two worlds together, her absolute resilience against a totally hostile system, and her staggering conceptual genius, we really see how she handed humanity the master key to decoding the universe. Her colleague, Hermann Weyl, summarized the sheer magnitude of her approach perfectly. He said, "She changed the face of algebra by her work." And it's true, mathematicians to this day literally just do ring theory her way. It was a complete paradigm shift, and it still forms the total backbone of abstract algebra as it's taught globally today. So the absolutely crucial point here is how all of this applies today. Noether's theorem acts as basically the ultimate required test for modern theoretical physicists. Here's how it works. First, you propose a new theory of physics. Second, you have to identify its continuous symmetry. And third, you must confirm the conserved quantity in an actual physical experiment. So whenever physicists are out there searching for the Higgs boson or developing crazy new models in quantum mechanics, Noether's theorem is the bedrock foundation they rely on to prove their math is actually real. Which really brings us to a final, pretty profound question. As we keep searching for the ultimate theory of everything, will Noether's hidden symmetries be the master key that finally unlocks the universe? It's just a staggering legacy for someone who literally had to fight just to be allowed inside a classroom. Well, thank you so much for joining me for this explainer. If you want more accessible, deep dives into the universe's greatest minds and concepts, make sure you hit that subscribe button for the Staiblocks channel right now. Keep learning, and I'll see you next time.